traveling in a straight line. Okay, it is exhibiting SHM into a straight line. Okay, so let us say if this is the reference position of origin or the central position through which this body is exhibiting SHM towards right direction, let us say, right, and thus it goes to a fixed point maximum, okay, till this point, and after that it just returns, right, and similarly it travel the same distance in the extreme to the left from the point of reference. Okay, so which I have shown to you is the same case. Okay, so here, and then again returning back to its original position like this. Okay, so this is the entire traveling path of, or when a body is exhibiting SHM, this is the entire amplitude. Okay, that is the maximum deviation from its mean position. This is the mean position, right? Let me write it. This is the mean position, and from here this is the maximum deviation to right. Okay, let us say this is P, right, and this is Q, right. Now from it the maximum deviation to the right towards P, and then return back, then maximum deviation towards left is till Q. So this is the amplitude, that is from P to Q, right, my dear friends. The question to us is that a particle executes SHM in a straight line such that in two of its positions the velocities are u and v, right. So let us say two positions are there. Let us mark it here, maybe A and here maybe B, any positions in between its path, right. So at the position A and at position B, at A, okay, so let us not write A and B, let us write it as because amplitude is denoted by 8, so don't get confused. Okay, so I'm writing it with a different color so that you can easily understand, right. So this is at A. At position A, the velocity of the particle is given as u. This is the velocity, right. And similarly at position B, at this point B, the velocity of the particle is given to you as v. This is also the velocity, right. So my dear friends, here let me put a pin over here. Yes, it's little better now. Yeah, so into this question it has been given that the particle executes SHM in a straight line such that in two of its position, let us say A and B, the velocities are u and v respectively, right, and the corresponding accelerations are alpha and beta. At A, the acceleration is given to you as alpha, and at B, acceleration is beta, and the condition is such that alpha is less than beta and alpha is greater than 0. That what does it mean? That at a position B, when the acceleration is beta, this will be greater than the position of than the acceleration at A. What is the meaning? That means the restoring the acceleration, that means this spring or the when the body is executing SHM at a point B at a higher degree of acceleration, you can see B is the greatest. Okay, that means from here the tendency of the body to return towards its mean position is higher, right? Because suppose you are stretching a spring till A, till B, till the maximum point P. Then if the point at point P, if you consider the acceleration and if it will be gamma, then definitely gamma will be greater than beta, which will be greater than alpha, right? Because the maximum restoring force over here is the restoring force over here will be the maximum, okay, and this one will be smaller than that. So here it's given that find the distance between the positions and the period of the motion. That means if the distance between A and B is, let us say, D, right, then it has been asked that what is the value of the distance between the positions and the period of the motion, right? And what is the period of the motion? The D need to be found, right? And what is the time period of the motion, okay? And the time period also need to be calculated. So my dear friends, if you remember, acceleration in a simple harmonic motion is given by omega square x with a negative sign. Why negative sign? Because this will be restoring, okay? So due to the restoration factor, this will minus sign will be there, right? This formula I think you remember very easily, right? A is equal to minus omega square x, right? Now from here we know that if we put the value of A equal to f m, since f equal to ma, and we write f by m as the value for this A, then we get that. You want me to write, since I'm just showing a small derivation, f equal to ma, then from here we can write A equal to f by m. So let us write f by m, right, which is equal to A, which is equal to minus omega square s, right? So this will give you the value of f as equal to minus m omega square x, right? And this is the value of the spring constant. So that's why in the formula you have seen minus kx, right? So I've just quickly shown through this step. This is of no use over here, but yes, how this will be in use you can see, right? So from here we see that there are two positions of the body at A and B, and the corresponding velocities are u and v, and accelerations are alpha and beta, right? So from this we can write that for the two positions A and B, right, let us say from the mean position it is x1, and from the mean position B is at x2, right? Let us write it x2, right? Hi Shuleman, very good morning. So since we know A equal to minus omega square x, using the same relation for x1, what we can write at A, what happens? Since A equal to minus omega square x, and at A the acceleration is alpha, you can see. So we can write alpha, the acceleration at a position A, can be written as minus omega square, and the position of that is x1, you can see here. So minus omega square x1, isn't it? Similarly at B, the acceleration is given to you as beta, right? So you can see the question in clearly into the description, okay? So beta is given as similarly minus omega square, and the position of this beta from the mean position, this is x2, right? So this will be minus omega square x2, my dear friends, right? Now from here, if you remember the formula, that velocity, let me squeeze a little, not much but little one, okay, or I can shift. Yes, it's better. So if you remember the formula, that yes, v is equal to omega root over of a square minus x square. If you remember this formula, right, I will not go into the derivation of this. This formula is very common into the SHM, and you should just recall it. You are not going to derive it every time, right? This will be helpful. Since v equal to omega root over of a square minus x square, and we know that v square, squaring both sides, will give you equal to omega square, and root will be eliminated. It will be a square minus x square, my dear friends, right? Hi Suleiman, hello, hello. So this will give you v square equal to omega square, a square minus x square. So if you write the corresponding values of the velocity u and v into this formula, then what will happen? In place of v square, if you write u square, then it will become omega square a square minus x1 square, isn't it? It will be like that, right? Similarly, if you put the value of velocity at b, which is v, so it will become v square is equal to omega square a square minus x2 square, isn't it? Because the value of x at the two positions a and b is x1 and x2, right? So these two formulas with us now, these two relations, u square equal to omega square a square minus x square, and v square equal to omega square a square minus x2 square, right? So from here, if you do the calculation, right, if you just subtract both of these, right, let us subtract it. If you, right, when you subtract it, what you will get? Into the LHS, u square minus v square, just subtract this one into the LHS. Similarly, this will be subtracted into the RHS, right? This will be subtracted. This will give you omega square a square minus omega square x1 square, right, minus omega square a square, and minus minus plus omega square x2 square, isn't it? Now from here you can see omega square a square and omega square a square will be cancelled out, right? And this will give you, let me squeeze a little, yes, and this will give you the value of u square minus v square is equal to omega square x2 square minus x1 square, right? We can write minus omega square, which can be taken as common, x1 square minus x2 square, right? This is the relation with us now. Now from here, what will be the value of, if you write the value of x1 from here, x1 can be written as, from here, x1 can be written as minus alpha by omega square, isn't it? Minus alpha by omega square. And from here, x2 can be written as minus beta by omega square. Why we have written it? Because we are going to use it. x1 equal to alpha by omega square and x2 equal to minus alpha by omega square and minus beta by omega square. Just substitute it over here, right? Then can't we write u square minus v square is equal to minus omega square, in place of x1 square, write alpha square by omega square, alpha square by omega square, minus, in place of x2 square, write beta square by omega square. In fact, when you square it, it will be becomes 4 times into the denominator. So it will become beta square by omega 4, right? And when you further move, you will get the value of, you can see omega square from here and omega square from here can be cancelled out. So this will be giving you u square minus v square is equal to minus omega square divided by, when one of the omega square is taken as common, right, here, or let us say 1 by omega 4 is taken as common, then here we have alpha square minus beta square, right? So here you can see omega square and omega square. This omega square will cancel this omega 4 in omega square times. So omega square will be left, I mean to say, right? So this will be giving you the value of omega square. So the value of omega square after cross multiplication, this omega square will be going to the LHS. Then omega square can be written as alpha square minus beta square divided by this whatever into the LHS u square minus v square will be coming to into the denominator of the RHS, right? So this will be coming as this will become u square minus v square over here, right? So this will give you the value of omega square as alpha square minus beta square divided by u square minus v square, my dear friends, right? Now from this, what is the benefit? Because the benefit we can find that we need to find the distance between the two positions of the SHM. This d need to be calculated. D equal to what? So to identify the distance, what we can do, oh my god, this is a power failure. Bear with me, my dear friends. Just a, oh my god. So is it visible now? Sorry, there is a power failure. So here we can see that yes, let me squeeze a more, yeah. So here we need to find the distance means the difference between x2 and x1. X2 minus x1 will give you the distance. Sorry for the problem you are facing, my dear friends, due to the power failure. So the distance between the two positions B and A was about to be calculated. This D is what, right? So D is nothing but this is equal to x2 minus x1, isn't it? Hi Mexican killer, hello my dear friend, is equal to x2 minus x1, right? This is D. This is the question to us, right? What is the value of D? So x2 minus x1. So what is the value of x2 minus x1, my dear friends? x2 minus x1 can be written as, tell me, it can be written as x2 from here alpha beta by omega square. It will become beta by omega square. I'm just taking the magnitude, that's why leaving the negative sign from here, right? Leaving the negative sign. Thank God power is restored. Sorry for the inconvenience, my dear friends. So it will be beta by omega square and x1 will be alpha by omega square, right? So just write it over here, minus alpha by omega square, right? What is the benefit of this? If it's not visible to you, I can just enlarge a little, right? Is it fine? Yeah. So x2 minus x1 is the difference between beta by omega square and alpha by omega square. And if you take the magnitude, then negative sign can be ignored for the reference. Okay, over here you can see minus beta by omega square. So the distance between the two position is beta by omega square minus alpha by omega square, which can be written as beta minus alpha divided by omega square, isn't it? I'm taking the magnitude only, okay? And beta minus alpha divided by, you can just put up the value of omega square over here. You can put up the value of omega square over here, right? Then what will happen? Into the denominator we have alpha square minus beta square, isn't it? divided by u square minus v square, u square minus v square. This is entire denominator. Now if you expand alpha square minus beta square, it will become alpha minus beta and alpha plus beta. So this will give you, so here beta minus alpha will be cancelled, and this will be giving you u square minus v square. This will go into the numerator divided by alpha plus beta or alpha minus beta, because you have taken the magnitude, right? So it can be written like this, because alpha minus beta and modulus of that is cancelled out with this beta minus alpha, right? Because a square minus b square, alpha square minus beta square can be written as alpha minus beta and alpha plus beta. And you can see alpha minus beta or beta minus alpha, when taking magnitude only, this can be written as beta minus alpha, can be written as alpha minus beta. This will be subtracted from one of the, this will be cancelled out from this one, right? So you will get u square minus b square by alpha plus beta is the distance between the two positions of the body exhibiting SHM. Okay, so d equal to u square minus v square by alpha plus beta. And this is your solution, my dear friends, right? D is equal to u square minus v square by alpha plus beta. If you want to see the entire solution, let me squeeze a little. It may be little smaller, but I think you can easily understand, my dear friends. Is it visible to you now? Yes, these are the two positions. These are the two positions. Okay. These are the two positions A and B for the body exhibiting SHM, and x1 and x2 are the reference positions which we have considered, and the distance between them is identified as u square minus v square by alpha plus beta. This is your answer, my dear friend. This is your answer, right? Now, the another part of the question was that what is the time period of oscillation? Time period of oscillation is definitely t is equal to 2 pi by omega. We can write t is equal to 2 pi by omega. This is that there is a frequent power failure, my dear friends. Sorry for the inconvenience. T equal to 2 pi by omega. So what is the time period of oscillation? This is the time period. Okay. This is the time period of oscillation. And we just put up the value of omega over here. Okay. So the value of omega will be, just put it 2 pi in the numerator, in the place of omega. Just what is the value of omega? Omega square was alpha square minus beta square by u square minus v square, right? Then omega will be equal to, if you take the root over both the sides, right, you get alpha square. This will become alpha square minus beta square divided by u square minus v square. So this is the value of time period of oscillation of the body exhibiting SHM into the given condition, right? And t is equal to 2 pi by this one, which can be written as, when u square minus v square going into the numerator, it will become 2 pi root over of, this will going into the numerator, right? This will become u square minus v square into the numerator divided by alpha square minus beta square here, right? So this is the time period of oscillation of a body exhibiting SHM into the given condition, and t is equal to 2 pi root over of u square minus v square divided by alpha square minus beta square, my dear friends. So this is the entire solution in front of you. For any query, you can put up into the comment box, my dear friends. And I think, yes, it's going to be 25 minutes for this session, so we can wind it up. And thank you so much for being connected. Keep on learning, happy learning. If you don't want to subscribe, no problem, my dear friends, but yes, your like matters a lot to me. Okay, Just like it if you find it useful. Thank you for giving this motivation and be connected. Take care. Bye bye. See you.